let's get going. So I am Chaz. I've been working here at Bluehost Endurance for 5.5 years. Been involved with building on various products and working on APIs and things like that as a software engineer. So I've been using GraphQL for a while. I wanted to give a presentation on it about 2 years ago. Never really ended up doing it. I picked it up again for a recent project outside of work that I wanted to work on, and so it reminded me I really wanted to give this presentation. So here we go. GraphQL may seem unapproachable. I think that may be one of the reasons why it seems like it doesn't get adopted very much here at Endurance. One of the reasons I want to give this presentation is to turn that around. This link, graphql.org/learn, is a great place to start to actually learn GraphQL. Easy onboarding documentation to figure out the basics. Don't go there yet, because I think you will be better served listening to this presentation first. I may be biased on that. So, let's get talking about GraphQL. GraphQL is a web service architecture. Okay, so that means you use it to create APIs. So it's comparable to REST or RPC as alternative web service architectures for building APIs. GraphQL is both a query manipulation language and a schema definition language. So it's kind of like SQL, where you can have your create statements to actually define your schema. And then apart from that, you also have your selects, your updates, inserts, and deletes for actually accessing and manipulating the data. GraphQL is kind of the same in that regard. Certain parts of the language can be used for defining schema and types, and the other part of the language is concerned with actually using the API to work with data. And actually, if you're familiar with SQL, GraphQL is considerably easier, I believe, to learn than SQL is. SQL is a really large language. GraphQL is much smaller. We'll blow past this a little bit, just a little bit of history here. Invented at Facebook in 2012 was GraphQL. Released in 2015 to the public. So this is one of the great things that Facebook has actually done for the world. Fairly recent development. GraphQL is now in the hands of a foundation just since November of 2018. It's in fact a hosted project of the Linux Foundation. Now, since its public debut, people have started using GraphQL. A lot of people, actually. Now, I might mention now at this point that this is actually a good time for you to learn GraphQL if you are unfamiliar with it up to this point. So it's effectively 3 to 4 years old, and it also has the benefit of having grown up at Facebook, so it went through that process of being developed before it was released. But 3 to 4 years, I think, is kind of a good time span to start learning a new language. It's not so new that you feel like a tool learning something so cutting edge, so trendy or whatever, and it's established enough that it's certainly a fixture in the landscape of API architecture at the moment. So if you're learning it for the first time, you're lucky. This is perfect. GraphQL can be used in many languages. It has a reference implementation in JavaScript. JavaScript has at least 2 good implementations. The reference implementation is good, and there's also another implementation called Apollo, which includes both the server and a client. We'll see a little bit of this code a little bit later, but it is also good. As a standard, you can of course mix and match. So you can use the Apollo client with the reference server implementation of GraphQL. That's totally cool. And of course, GraphQL also works in Perl. There is a great Perl implementation on the server side. We're going to see some code for that a little bit later. I thought these 2 languages would be kind of the most interesting for this audience, so some of the example code I've written are in these languages. The Perl implementation is a little bit behind spec, but we're working on fixing that. I've actually sent some pull requests to the author, and he's very accepting of pull requests. So if you want to contribute on GraphQL, the Perl implementation, or any of it, I'm sure anyone's open to you helping out. Okay, very quickly, before we dive too far into GraphQL, I want to take a slight detour and talk about REST, because that is kind of the big alternative web service architecture that you would consider. And the reason I want to talk about it at all is just so that you have some sort of frame of reference, so that you can pair what we'll learn about GraphQL with what you know about REST. And if you're unfamiliar with REST at this point, just go ahead and let this information wash over you at the moment. It's not super important. But REST has 6 main constraints that define it as a web service architecture. Now, the first is your client-server architecture. So this is the idea that we have separation of concerns, that we have server that's responsible for storing data, and we have the client that is responsible for viewing the data. Statelessness is another big constraint. So each request is kind of new and provides all of the information needed to fulfill a request. There's no implicit state in the connection itself. Cacheability, both on the browser and in intermediaries, data can be cached. Talking about intermediaries, number 4 is the layered system. That is a constraint of REST, and that is you can have proxies that can talk to the client on behalf of servers. Code on demand, this is a lesser known or used one, but this is just the idea that the server can send executable code to the client in order to accomplish things there. And this would theoretically be in the form of a JavaScript that it's executed in a browser. And a uniform interface, which is kind of the big one. I want to zoom in on uniform interface just really quickly and talk about that. So resource identification requests. This is the idea that there's a certain way that you interact with REST APIs. There's URLs, for example, and they provide representations that are served back from the server. Speaking of representations, resource manipulation through representations is kind of a key feature here. This means that the storage of the data is decoupled from the actual representation that's served back from the server. So for example, it doesn't matter how it's served, but I can return like a JSON document or a YAML document. Those are called representations. And it can be stored totally different on the server. Self-descriptive messages, which is the idea that when I request something and get something back, the response has all of the information that I need to understand the resource being served, like the content type, how it's encoded, and then as a client I can deal with that information. There's no sideband information, there's no like implicit knowledge that I need to have. And then hypermedia as the engine of application state, which is the idea that you can discover an API in the same way that a user might discover a website by landing on the home page. They can follow links and know what they can do just by following the links and looking at what is offered to them through that. All right, thanks for bearing with me through that diversion. We're jumping back into GraphQL now. Just keep those things in mind, and just in your mind make comparisons on contrast with REST here. So this is now the language that we're going to talk about here. So in terms of using an API, there are 3 types of operations that you can do with a GraphQL API. You can make a query, you can make a mutation, or a subscription. I'm only going to talk about queries and mutations. Subscriptions, I just want you to know for now, you can look into it later, but this is a defined mechanism such that you can arrange for the server to push information to the client. So there is a defined way to do that in GraphQL. So let's talk about queries. Here is our first example here of what a query looks like. We'll point out a few features. The query starts with the query keyword. This is the operation type of the query. And then it's given a name. This one's called get main domain. But the name is arbitrary. You can name any query. You can name queries whatever you want. So the first line contains the operation type, then the operation name. This middle part here is the fields. So this is this represents the information that you're actually getting out of the API. In this case, what I want to get out is, for example, the main domain of an account. And this main domain happens to be an object type that has subfields that I can also access. In this case, I can get the domain, maybe a list of name servers, and the registrar of the domain. So nested fields are also possible in GraphQL, and they're accessed through extra braces, those curly braces that you see there. If I were to execute this query, I might get a response that looks like this. So the top box in this slide is the query itself, just a repeat, and the bottom is just plain old JSON. This is what you would get back from the server. Now notice the shape of the response. It mirrors the structure of the fields in the query. Okay, so I asked for the main domain to be resolved and 3 subfields. And in the response, I get back in the JSON a main domain with a sub-object with domain, name servers, and registrar as fields that are filled out with data. Main domain, the domain, the name servers, and the registrar. It's a perfect mirror here. Now this highlights 2 important benefits of GraphQL, or at least main features. First is you can ask for only what you care about, and the server won't waste time evaluating and then wasting network bandwidth returning things that the client actually doesn't need. So for example, if I don't actually need the name servers, I'm just going to drop it off the query, and I won't get it in the response. And the other thing that this sort of structure allows is you can crawl this web of nodes along edges in a reasonable way, because this is assuming that data is, you can view the data as kind of a graph where I've asked for one thing, I've asked for the main domain, so that's the main domain node, and then from there, what else can I access? Well, I can get the domain, the actual string form of the domain, a list of name servers, and the registrar. And so those are different nodes or fields in the graph that we're crawling here. So think of your data in terms of a graph, and you'll have a much easier time understanding and grokking GraphQL here. So this is the basic form of a query, and to be honest, there's not much more than this. But in this particular case, we can actually drop off the name of the query. The name is an optional thing here. And in fact, the query keyword is also optional. So we could make a query that looks like this. Now, naming the query actually does have benefits, so you may want to name your queries anyway. On the server side, in logs, for example, you may be able to identify a query based on the name that you give it, so that's still useful. But I'm showing you this form because you'll see this commonly as well, just chopped off the query and the operation name. Okay, let's look at another query here. And by the way, at this point, let me just say that this can totally be interactive. My style of presenting is I just kind of go, and this is a little bit harder because I can't like see people to see how they're responding, to see if they have a confused look or whatever. So feel free, I don't know if there's a chat room for this, but if you have any sort of questions, don't wait to the end, just jump in and we'll see if we can get those answered.
I have a question.
What's up, Jeff?
I didn't see any identifiers as to find out which main domain you were looking for.
Good question. So in this, so in this query, I decided the first query I wanted to show you just to be the simplest. There is a way to specify specifically what you want, but for this simple query, I'm just assuming that this is getting the main domain for an implicit user, like the logged in user, for example.
So you're running the method on a user or something like that?
Yeah, so I'm assuming that the API layer on the back end is able to figure out who the current user is and then get the main domain for that user.
Okay.
But it is, like I said, it's possible to specify more precisely what you want, and that's actually what I'm going to talk about on the next slide. So that's a good question. Again, if anyone has any other questions, just jump in, interrupt me. That's the way to do it here.
So I'm going to assume, Jay, so then one of the next ones you're going to do joins as well, or relationships
Yes.
between things?
Yep, we'll see that. We'll see that as we go along. I don't know if it's the next slide necessarily, but. Okay, so this query that's on the screen now is a little bit more complicated, but it has the feature that Jeff was asking about, and that is, well, how can I specify more precisely what I actually want? And in this case, this is a query that gets, for example, the mailbox of a user. So if I'm a user and I, for example, have multiple email addresses, then this is the way that I can get the mailbox for a particular account. You'll notice that this syntax here looks kind of like a function call with named parameters. And in fact, as we'll see, as we'll get to look at some code later, that's very similar to how it's used and executed on the back end. So this is basically saying, get me the mailbox with the email address that matches this email address on the screen here. Okay. So after that, we've seen this before, where the opening curly and then the list of fields. So that's accessing just those fields within the entity that I'm requesting here. Okay. Now, so arguments are great. This unfortunately mixes data with the query though. Like if I were to construct this query, I would need to maybe interpolate the data into the query, which is less good. So there's a different way to do this called using variables. Okay. So this is the same example using a variable instead, where I specify on the query line a declaration of the variables that my query can accept, and then within the fields I can use those variables. So whereas before we had kind of hard-coded this value for the email address, now we've ripped that out and it's now a separate thing. So variables can be passed alongside queries, and that's this thing that you see at the bottom here where it says email address. That's just plain old JSON. So you can specify it, that's an object, obviously a JSON object, where the key is the variable name and the value is the value that is associated with that variable. So you don't have to do string interpolation. This would be very similar in concept if you're familiar with SQL to bind variables, so that you don't need to like build SQL queries or anything like that. It's really nice. All right, now at this point, I want to take a step back from looking at the language itself and defining how this would actually be used over HTTP. Okay. So there's two standard ways that we actually send queries to a GraphQL server over HTTP. We can use a GET request, like is on the screen now, where I have this simple query where I'm accessing the domain field of the main domain, and I'm just using the query parameter called query, and the value of that is my GraphQL query. See that at the bottom there? So this main domain and opening curly and domain, that's not JSON or anything else. That's just a string of GraphQL query. You can also use a post, and you would do it like this. Do post, use a content type of application, JSON, and then you have a JSON object that has a query key, and the value of that is the GraphQL query. Now, you don't have to think about the semantics of HTTP here. You can basically just forget about RFC 7231. This is just, we're operating under different constraints than we would if we were doing REST. Okay, so we don't need to think about like idempotency or anything like that. This is, we're basically using HTTP as HTTP uses TCP, and that is, it's just a transport layer. We can use GraphQL over any sort of transport layer, but this is commonly done using it over HTTP. So don't worry about your REST knowledge in terms of which method should we actually use. In GraphQL, just a get or a post is just fine. You can also do it this alternative way if you're doing a post where you specify the content type as application GraphQL, and then the payload of the request is just a GraphQL query. Now, if you do it this way, I don't believe that you can also pass variables, which you can do like this. For example, if this were a GET request, you can give your query, and then another query parameter called variables can be a JSON encoded string that has your variables that will go along with the query. You can do the same thing with post, where you have your query in the JSON object in the request and a separate key for variables that contains another object with your actual variables in it. Okay, so I'm getting a little bit low level here, but if you're familiar with HTTP, I think this will help you understand like what's actually going on here. It's not magic, it's just using HTTP as a transport. All right, now I want to talk about the first tool, and that's called GraphQL. So in development mode, when you are developing a GraphQL API, you can enable this pretty much in any backend implementation of GraphQL. And it's basically an in-browser IDE of your API. So I'm going to switch tabs over here now. I need some water. And show you what that looks like. So this is GraphQL. I just want to, at this point, walk you through some of the features. So here, on this left side, this is where you enter your query. On the right side, this is the response you get back. Okay. So again, notice that I can just ask for what I'm interested in, and the response will mirror the shape and return just what I'm asking for. GraphQL has some nice things like auto-completion. I'll tell you in a second how that works. And it's a good way to kind of prototype and make sure that your API is working. This can form some basis of documentation as well. So you can deliver this alongside any users of your API to help them also learn your API and learn what is possible. So down here, if I were to have an endpoint that needed query parameters, you can specify it down here. Now, I haven't fleshed out this demo too much, but I believe there is an endpoint or a field called echo that can take a query parameter. So I'm going to do that now. Do an echo. Remember, this query name here can be anything. It just helps in diagnosing issues. All right, so I'm going to define something here. This is going to be a string. Now you're seeing things that I haven't talked about yet, like the string type. I haven't talked about types yet, but we will get there. Okay, so I want to do an echo here. I want to pass this echo a message, and I'm just going to pass it the string here. Okay. If I try to run this, I actually don't get any data back. I get null. That's because by default, all fields in GraphQL are nullable. So if there is no information, it will just return null. But since I'm using a variable, I can define it down here in this section. So I can say, again, this auto-completion is really nice. It knows what I should enter. So I'm going to auto-complete string, and I'm just going to say hello. This is GraphQL. Okay. If I run this, it echoes the correct thing over here. So what this is doing is I've defined this query that takes a variable that I'm naming string, and it's using it as an argument to one of my fields. And then what the server is going to do, we're going to see the code for the server in a second, but what that's going to do is it's just going to spit back the whatever argument I give it. Okay, this is one of the simplest things that you can do. At this point, I'll just point out a few more features of GraphQL. It keeps a history of some of the last queries that you've done, so you can easily get back to other queries that you were working on before. It's pretty nice. It does have inline documentation. Again, I'll talk about this in a second, but every endpoint, every field that you define in your schema, which we'll see in a second, can potentially be exposed right here in a discoverable format by the user. Pretty slick. So that's GraphQL. When you're learning GraphQL, you'll want to become familiar with GraphQL because it's pretty cool. All right, back to the language. I'll just point out a few more things about the query side. Like I said, we've covered the vast majority of it already. GraphQL is actually pretty easy. It's not too bad. GraphQL, you can do comments. If that wasn't obvious before, it should be now. You just use a hash and the string, and up to the end of the line, that's a comment. In GraphQL, you can also have multiple sibling fields. So in my test server, for example, I have a main domain field that I'm using to get domain name servers and registrar. And I also have a different field called add-on domains, which returns a list of all my other domains that are added to my account. I don't need two separate requests for this. I can just do it all in one single GraphQL request. And the shape of the response will mirror precisely the two main fields that I'm getting here. Now, you'll notice that there's some repetition here in my defining of the name, the domain, the name servers, and the registrar. The GraphQL language has a feature called Fragments, which can alleviate some of the repetition that may be common in some types of queries. And it works like this. Okay, I'm just going to define a fragment called domain fields on the domain type. We haven't seen the domain type yet. I'll show you that when we actually look at the schema definitions. But I'm saying I'm defining a fragment over the domain, over domain, calling it domain fields, and listing the fields that I want to get back with when I use this fragment. And then up at the top, when I define the get domains query, I'm actually using the fragment in both of my my subfields definition in order to use it. Okay? Does everyone see what's going on there? The syntax is a little bit interesting. You may be familiar with it if you're familiar with ES6, for example, the ... in the domain fields. It almost looks like some structure expansion going on there. So this is a neat feature to reduce repetitiveness. All right, I want to talk about execution. So how is this query actually executed? Well, it turns out that sibling fields are resolved or can be resolved concurrently as the executor follows edges through the graph. So in this instance, I have one root field that I'm asking for. It's called the main domain. And then I have subfields that I'm asking for, and those are sibling fields. So domain, name servers, and registrar. So what this is going to do when it's executed is main domain is going to be resolved first. So the server is going to resolve that. That's a language that's used in the back end when you're looking at implementing these. So I'm using the language that we'll see a little bit later. So the main domain is resolved first, and then after that, domain, name servers, and registrar since they're on the same level, can be resolved at the same time. Okay. So this can be used to optimize things. We're not going to do things sequentially. And this will help with some performance. Mutations. So this is the second type of query that I wanted to talk about, and the last. So not only can you query to get information back out, but you can also perform actions on data. You can mutate data. In this case, for example, if I had a field called assigned domain, which added a domain to my assigned domains list, it might look something like this, where I pass it an argument called the domain. This is the domain in a tech.ninja, the domain I want to add. And as with queries, you can specify what you want to get out of the things when they resolve. So assigned domain, even though it's a mutation, will resolve to certain values. In this case, it will resolve to an object type that has certain fields, subfields that I can access. So it's very, very similar to a query. Just notice the new operation type keyword. It's called mutation. So instead of query, just use mutation there. Otherwise, like I say, very, very similar to a query. Now, just like when implementing web architecture in REST, where you can have some operations that have side effects and some that don't, and you should use get queries for things that have no side effects, or at least use, put or post or whatnot for things that do have side effects. So it is in GraphQL. You should use a mutation for things that have side effects and a query for things that don't have side effects. And just like REST, there's nothing that really enforces that. You should just do it that way because it's the right thing to do. Okay, so again, just like queries in a mutation, you can use arguments, you can use variables. Pretty much all of the features that are available in defining a query can be used in a mutation here. All right, and that's basically it for mutations, very similar to queries. Now, if I were to execute a query, sometimes it will fail, right? So what does an error look like when either the server is not able to resolve data, or if there's something else wrong, for example, with the query? We should look at what errors look like, because there's a standard way that they look. So if I execute, for example, this query, get mailbox, and it has a problem getting or resolving the num messages field, I might get a response that looks like this. So it's going to return as much information as it can. It's going to provide a mailbox with the provider. Say the provider was able to get resolved, but not num messages. We see that num messages actually returned as null. So that is a core feature of GraphQL. It will return as much information as it can, and it will tell you about errors for the things that actually errored out so that the client can resolve that in whatever way the client feels that they should. So in this case, the shape of an error is pretty much always the same. The errors is a key on the response. It's an array of objects, and the objects have a message, which is defined by the server. It can be anything. And then a path to the field that is associated with the thing that failed, the error. Okay? All right, and that's actually that's the bulk of the features with actually using a GraphQL API. It's not all of the features. There are other things that you could learn, like directives and other things I didn't mention, like the fact that you can have default values for arguments. That is possible. So there are certain language features I haven't covered, but what we've done so far is the bulk of it. Now, I want to talk about more of the back end. What does this actually look like? How is it defined? And to do that, we have the the GraphQL schema definition language, the SDL here. Now, it's going to look very similar to the query and mutation part of the language, just like SQL. In SQL, create statements kind of look similar. They follow the similar rules to selects and inputs or inserts and whatnot. So it's beneficial for you when you're studying GraphQL to be sure that you understand what it is you're looking at, whether you're looking at something that's querying something or mutating something, or whether what you're looking at is actually part of the SDL. It's good to be able to quickly discern what you're looking at so that you don't get too confused here. So this is how you would define schema. In defining schema in GraphQL, it's all about defining types. So this is the type of domain that we've been using all along. It could be defined as something like this, where I have a domain type and it has these specific fields that can be resolved. In this case, domain, name servers, and registrar. So this is called the object type. It's a type that can have subfields, like an object. It's got a strong correlation with a struct or an object in a programming language. So first up, you define type, use that keyword type, and then you name your type. That's what domain with the capital D is. That's just giving it a name so that you can use it elsewhere within the schema. And again, you define your fields on an object type. Now GraphQL also comes with scalar types and supports scalar types, and it comes with some primitives that are built in that are useful, like string. I don't think anyone's going to be too surprised by the built-ins that GraphQL provides. You can do string, an int, floating point numbers, booleans. This ID one is a little bit weird, but it's basically a string. It acts like a string on the back end, but it's meant to kind of semantically identify the field as something that's opaque, that the user shouldn't really be reading. It's a non-readable thing. You can also define your own scalar types using the scalar keyword. So in this bottom example, I have scalar myType. MyType is going to be the name of the new type. Now you'll notice that there's no definition of what that actually means, because that actually needs to be defined in code. You would define that in code in your backend, what myType actually means in terms of its what values it can take and things like that. You can also do an enum type. So enumerations are possible. Pretty simple. I don't think I need to spend too much time on this slide. And that's it. In terms of defining schema, those are the three types: object type, scalar type, and an enum type. So again, pretty simple. GraphQL is not a large language. It's very, very approachable. Please approach it. It's not scary. Now, when you're working with types, you can also use type modifiers that change kind of the behavior of what the type means. And there's only two of these. So there's the bang, and this declares a thing as being not able to be null. So if you recall, I said that by default in GraphQL, everything is nullable. Everything can return null. If the field doesn't resolve, or if it just doesn't have a value, it would be null. Well, in your schema definition, you can say, well, this thing can't ever be null. If it is null, then there's an error, there's a problem. And you just append a bang to the type. In this case, I'm using string, but you can have an object type that's non-nullable. Just put a bang at the end when you actually use it. And the second and last type modifier is you can declare a thing as being a sequence or a list of things. And to do that, you just wrap it in square braces like this. So this declares a list. In this particular example, I have a list of strings. It can be 0 length, it can be an empty list. And in fact, since I'm not using bang, this can also be null rather than an array at all. But you can use them together in these ways. So if I want a list of strings that can't be null, you include the bang after a string, but within the square parens. If you want a nullable or a non-null list of strings that can be null, you put the bang after the closing square paren. And if you don't want nulls at all, you don't want the content of the array to have any nulls, and you don't want the array itself to be nullable, you can use bang bang on either side of the closing paren. Okay? Like I said, those are the only two modifiers. Okay, and that's all I wanted to cover for the schema definition. We'll look at some real code in a second. Now, in fact, because the next part is the actual implementations of how this actually works, what it actually looks like in code. How are we all doing? Nothing too crazy so far, right? It's pretty easy. All right. So what does this actually look like? So I had hoped to be able to have a more full example, but what I've done is I've implemented kind of a sample API, an example API in Perl using Modulicious, and so we'll see some of that code, and then I've also developed a front end for it using the Apollo client, and that code will be in JavaScript. So we'll get to see some Perl and some JavaScript here. So this is what the back end could look like. This is a Modulicious Lite app, as you can see. So it's very, I mean, if you're familiar with Modulicious, there's nothing crazy going on here except we're using a plugin called GraphQL, which provides the integration with the GraphQL server. That's it. So for this plugin, you define what endpoint you want to give it. And by the way, I don't think I made a huge point on this, but as opposed to REST, you pretty much just have one endpoint, right? And it's typically /GraphQL on your API. So there's not a whole lot of usage of URLs in GraphQL at all. You just have one endpoint that you send all of your queries to. So in the plugin, you specify what endpoint, and it'll mount the GraphQL server on that endpoint. Then you need to give it your schema. This is what we were just talking about, where you use the SDL, the schema definition language, and you provided a schema so that the server knows what it can do, what it can respond to. And then you give it a root value. Now the root value is every query or mutation needs to start from someplace. So this is what the root value is for. It's a structure that defines what are the things that I can do when I don't have anything yet. So this is the starting point, and we'll see what that looks like in a second. I've pushed off all of the actual code for this in a module called MyAPI, as you can see. And we will look at that code. And then this last thing that I'm passing to the GraphQL plugin is just enabling GraphQL, and that is what allowed us to actually see GraphQL here. Okay, so now let's look at the MyAPI module. It's a bit longer. I should be able to scroll it, I think. Okay, perfect. So, use GraphQL schema. They're on line 3. The lines aren't numbered, unfortunately. I apologize. But use the schema, and that will allow us to actually insert the SDL into a schema object that will compile it for us. And what that looks like is down here. So I'm actually using Mojo Loader in order to actually load things out of the data section of this Perl module. And this is actually where I've defined my GraphQL schema. So I've defined a type here, and I've a domain type, and then there's a special type called query. And this is the thing that defines your top level things that you can start with. Okay, so that's why I was able to have a query that accesses the main domain or accesses the add-on domains just directly from the top level of the query. And from there, once I have a domain, then you can access subfields. But you need to start from someplace, and that's what the type query is for. So query is a special name that is used to represent the top level things. So this text is passed to the GraphQL schema object and compiled and returned to the plugin so that it can actually do this stuff. Now the rest of this thing is just mostly the root value. Oh, look, it fits on one page basically. And so this is the code that actually resolves the fields. So for example, main domain. In this example, you know, all of the data that my API returns is kind of hard coded here. You would get this information from a database. The nice thing about GraphQL is that you can basically plug in any sort of data model on the back end and reuse it as a GraphQL plugin. In fact, many plugins can just consume an open API spec and build out the GraphQL schema for you, which is pretty nice. And that's basically it. I mean, this code is pretty simple. I just, in my main domain resolver, I'm basically just creating a my domain. In this case, I'm just filling it with hard-coded data and returning that thing. So you can return a blessed object with methods that represent the field, the subfields that can be accessed. You can also just return a plain data structure like this. In this case, these are my add-on domains. So over in GraphQL, for example, I used this query as an example in my slides, if you remember. If I run this query, it's going to show me this data where here are my add-on domains, here's my main domain, and then I'm also just using the simple echo thing. And these are just sibling root level fields that I'm accessing here, and then the shape of the response, of course, mirrors what I'm actually requesting here. And so that's it for the back end. I mean, this is a really simple example. This doesn't necessarily showcase the power of GraphQL in terms of, like, you know, navigating deeper into a graph of more complicated structures. But the idea is just very similar. Just going these two levels have hopefully showed us that it would be possible to reach deep down into a graph and actually get a lot of information just with one single request. So you can do pretty complicated queries and get data in the shape you want back, and it's pretty slick that way. Now I want to jump over and show you what a client might look like. And so I'm using the Apollo client, which has integrations with a lot of frameworks, a lot of front-end frameworks. This example uses Vue.js, but it's going to be very similar in, for example, a React or something like that. And it's not much code either. As you can see here, I define a template, and then I define my script, and that's it. That's the bottom of the script right there. So the things that I'll point out that are actually involved in the integration with the client here is, there's not much to point out in the template except to show that I can use the variables, the properties, the actual component data. I can use them in my template, and these will be just automatically provided and filled out by the Apollo client when I define it below in the script. So down here in the script, in my component, there's an Apollo key that I can add to my Vue.js component, and then I can define queries or mutations. Well, mostly queries, because mutations typically are reactive, like you click a button and a mutation happens. But this is what the query would look like. And you can define the text or the content of the query right here. So we've seen this one before. And you can also do all sorts of things with Apollo, like set the poll interval. In this case, I'm setting it to 10 seconds so that when I load this in a page every 10 seconds, this is going to make sure that my main domain is showing accurately. You can specify things like caching policy. We'll talk about caching in a second, right before we wrap up. But so there's a lot that you can do with this client. It integrates really nicely into components-based web frameworks, makes it really easy. If you wanted to, I don't have a whole lot of experience with like server-side clients. So for example, if you wanted to consume a web service that was a GraphQL on the server side, but presumably there are clients that make that easier. I mean, you can use just an HTTP client, right? As long as you're familiar with how to pass queries, like using the query and the arguments, query parameters, and things like that, which we did talk about. So you can totally just use an HTTP client, but some of these other clients, like the Apollo client, can make it just a little bit nicer to actually work with GraphQL. All right, we're almost out of time. I just wanted to wrap up with a few special topics, and then we'll be done. So introspection, I mentioned this briefly, but you can actually introspect a GraphQL just using queries. So there are certain fields and types that are prefixed with a double underscore, and those are special to GraphQL and allow you to actually look at what you can do. And this is actually how GraphQL does its documentation over here. So, for example, if I open up my network tab and do a refresh of this page, you'll see that when GraphQL loads, it actually makes a request to GraphQL, which is the endpoint I defined. And this is the query right here that it does. Okay, so it's doing a query on underscore schema and defining fields that it will get that allow it to get, for example, these definitions of what the fields mean. I didn't talk about this, but when you define schema, you can also define kind of inline documentation for the various things that you're adding to the schema, so that when you look at GraphQL, you can define the types. Like the domain is a domain name, and what the various fields are. So you can navigate and explore the API using this. If you were a client, I mean, you can do the same thing that GraphQL is doing if you were writing a client that wanted to do some introspection on the API. So that's pretty cool. Caching is the next topic. Let me switch back over here. So caching, because GraphQL just uses HTTP as a transport layer, we don't take full advantage of what HTTP offers, and that's especially true for caching. Fortunately, most of our GraphQL clients kind of do their own caching. In fact, they can support more complicated or at least different caching policies than you typically can with REST, or at least using HTTP caching itself. Of course, you can also implement your own caching policies within REST if you wanted to kind of bypass what HTTP would provide to you. Rate limiting. So GraphQL queries can be large and complicated, so that means that we need to be smarter when it comes to rate limiting APIs. You can't just count the number of queries and call that good, because one query might consume a lot of resources on the box. If you're familiar with the GitHub version 4 API, it has an implementation of rate limiting that you might want to refer to that calculates the complexity of the query that you're asking for in order to determine what your rate limit should be. And in fact, it's probably beneficial to implement more, smarter rate limiting within REST, even if you just wanted to stick with REST anyway, because even within REST, some endpoints are more complicated than others. Okay, that's it. We're done. So the conclusion is GraphQL is fun. My goal giving this presentation is to just make more people familiar with what's available. Is GraphQL better than REST? Maybe, maybe not. REST is awesome too. REST is well established. It's almost 20 years old, actually. Can you believe HTTP 1.1 is like, I believe, almost 20 years old now. So REST is still great. GraphQL is an alternative that you can consider. So, thanks everyone. Is there any last questions that I can answer? We're basically out of time, but maybe we can answer one or two.
So, you mentioned at the start of the talk, your hope is to try and get more people interested and influence a change here at EIU. Do you have any implementation here in beta or anything like that? Or is this all work you've done outside from your own personal interest and learning?
Great question. So I don't know how well the audio, I'll repeat it. So the question was, do we actually have, do I personally, or do we as a company like have any examples of GraphQL actually being used within the company? And I don't yet. I'm working on a personal project that I hope to actually deploy for use by the company, but that's also kind of a side project. So most of what I've done is just side projects. In the Bluehost division, I know we use REST a lot, especially for our customer-facing things. Like I said, REST is still good. But yeah, I would like more people to consider it, and I don't think it has been ignored completely. I think people are looking at it, and they just may not be completely familiar with it. And so I just hoped to be able to provide more exposure to it as a viable option. There are many companies that are using it. It is fairly popular, but it's of course not the only game in town. You can't go wrong going with REST either. REST is also great.
I think it depends a lot on your use case, right? Because
it does.
The idea or the advantages of GraphQL are when your client might be in a mobile space with limited bandwidth, and instead of making 7, 8, a dozen REST calls, you make one GraphQL query to the server and get the exact pattern of data that you want, that the client specified, rather than getting everything from the REST API endpoint through several calls, and then the client having to parse that and say, well, I only want this bit and this bit. So,
yep.
So a real well use case for me personally, right, is right here inside where that unlimited bandwidth, so to speak, right? The how GUI, if you pull up the server page, does 7 or 8 API calls, right? But it doesn't even do a simple one that I want. It says, for every server that's in a failed post-provision state, give me the relationship to that state being caused by a WHM, cPanel license being expired or not activated. Because that's a really easy one for me to fix, but I can't gather that data because we don't have it in the existing client space, that query. And if I want to go onto the how server itself and write a big long one-liner that does my complex joins, that's more effort.
True.
Whereas the promise of something like GraphQL is what I've asked you before. As long as I have my schema defined in my client JSON request, I can just specify the relationship between the fields that I want back, and it's there on my client-side form. And that's one of the big promises, right?
In fact, that is, I believe, one of the driving forces for its development at Facebook in 2012, because especially back then with the limited bandwidth on mobile networks and whatnot. Absolutely. That's a good selling point for it.
Thanks, Jazz.
Thanks.